My name is Jeff Barber. I'm an architect in the state of Missouri, and I'm also the MU Extension Housing and Environmental Design Specialist. And I'm here to talk to you today about taking shelter from the storm and building a safe room for your home and small business. Basically, what we're going to look at today is a standard that is available to the public. It's a FEMA document called FEMA 320. And what's nice about this, in the way that it's been developed, is that you have in here a very concise case for why we have a need, first of all, for a safe room in the home. And then secondly, you have a series of drawings. And what I really like about this new edition is they've bound them into the book in the back. And there's about 6 or 7 different ways that we can build the safe room in our home, including wood framing, concrete masonry, and other building methods. So it's not just a singular method, but several approaches that we have that can help you out. Now, one thing that I like to do when I start out talking about this is to maybe kind of go back to some common sense, and that's kind of what we're known for in Extension, is unbiased information, kind of a practical or common sense approach to things. And we have some stories that we've used as children that kind of help us to remind ourselves of what maybe makes a good structure in terms of resisting wind. And we all remember the 3 little pigs and the straw home, the stick home, and then the brick home. And it seems like as you step through there, the one thing that you really get to is that it's mass, and it's a way of locking that system together to resist the big bad wolf in this case. So to make the case quickly, and I don't think that it takes a rocket scientist to understand this in Joplin, Missouri, but when you look at a map of the wind zones, we have 4 different wind zone classifications in the United States, and the storms in these situations have hit up to 250 miles an hour in this area. Now, a lot of the information that is in the FEMA document is based on a small town in mid-Oklahoma, Moore, Oklahoma, as a matter of fact, which was hit by no less than 4 Category 3 tornadoes in about a 20-year period. So we like to be research-based. There's nothing like the real world and seeing how things actually work. And in the case of one of those tornadoes in Oklahoma, we actually had a situation where the winds reached a peak of 318 miles an hour, pretty substantial. So we want to look at a document or a map here that shows us the frequency of Category 3 or greater wind events in the United States. And when we look at this, we can see that there's this dark orange area that kind of reaches up in the southwest corner, what we call the 4 gateway counties in Missouri, and out into Oklahoma. As you get down towards Moore, Oklahoma, and Oklahoma City, it's a solid red, and it indicates that in the orange that we've had 11 to 15 Category 3 or greater tornadoes from 1950 to 2006, and that's per roughly 2,500 square miles. Now, you take that and think about just the last few years since 2006, and I'd say that would bump us closer to the red category there. And as we also know, in this, there's a new scale, the EF scale, but in the older scale, the Fujita scale, unmodified, you had F0 where you had some damage, maybe some debris or things out in the yard. And as you move through, these will look more familiar. F1, some roof materials. F2, a roof actually being demolished. F3, walls beginning to come apart. F4, essentially the structure demolished flat to the ground with some pieces standing. And then in an F5 condition, basically wiped flat off the foundation. What we learned from our F4 storms in Moore, Oklahoma, is that there were certain portions of the house that tended to stay and survive these storms, and those ended up being the interior rooms, the hallways, the bathrooms, everything that weatherman reads off to us as the places to go. it's because we know those things survive during those storms. So that becomes the basis for a lot of what we're going to talk about today. So whenever we take all those factors and we put them into this chart that FEMA provides for us, you see the wind zones and then the number of tornadoes, and you'll notice that we're down in the bottom right-hand corner, and it's arguable as to which of the four that we might actually land in. But when you look at this, the one thing you'll notice is you're firmly in a high-risk category here. So the reason that we should consider doing this is very great. Now, one of the things I'd like to talk about is what we think we knew about wind. And I can remember this from being a youngster, that when the tornadoes would come, what would everybody tell us to do? Well, you know, crack the windows and all that, go down in the basement, open up the windows and so on, because it's the pressure that causes the house to come apart. Well, what we know is that part of that is right, but really what it amounts to is kind of a windward-leeward situation. Whenever we have openings that open up into the home and wind can come in, the wind that's blowing over the top of the structure actually causes suction forces on the top and then on the back side, as you can see in the diagrams here. And so once we breach that outside wall, the structure is more inclined to come apart. So information that we've learned from this and then incorporated into design and construction is simple things. The one on the left is if we use a hurricane strap or something to hold the roof on other than just a couple of toenails per rafter, we can hold on to that moment. I know we've all watched the Weather Channel and we've seen, you know, that moment where the whole hat of the house, the whole roof kind of tips and then comes up and turns away. What we're trying to resist with the tie downs is that moment of tip, okay? If we can stop that from starting in the first place, then we can resist a lot more in terms of windstorms. We also know that when we're designing these structures that wind-blown debris is a big issue. In this case, we had a piece of plywood that went in and chopped through the tree. I think we've all seen stories of the straw through the tree or the garden hose. I heard in one case a garden hose was in a tree here in Joplin. It wouldn't surprise me one bit. Also in this is some imagery from the 2003 tornadoes in Battlefield, Missouri, and this was about 2 blocks away from, again, rather complete destruction. In this case, if my story's correct, it's either this house or the house next to it. They were in the bathtub, and above, in the shower portion of the bathtub, a 2x4 actually came through the wall and in through the material of the surround. They were okay, but it did penetrate through the house. And what's important to notice here is when we talk about the key aspects of a shelter, look at what we're trying to protect ourselves with in this house. We have vinyl siding, and right below the vinyl siding we have a thin foam board about 1 inch thick, and then you have fiberglass insulation and studs behind that. Not exactly what you'd try to protect yourself from flying 2x4s. So you'll notice that the debris hitting the vinyl basically disintegrated it into small pieces. The other thing that we know is some basics of physics. You know, the kids right now are out playing football, and they learn this equation real fast. Force equals mass times acceleration. You can be a big guy, and you don't have to move real fast, but you can hit pretty hard. Or you can be a little guy, move real fast, and hit real hard. Knowing all that, when we come down in and we look at the areas that we want to consider, the location of a safe room is important in the home. The foundation for that safe room becomes even more important because that's what's going to tie it down and help us to ride out that storm. The next thing is to tie it down and tie it together. It's one thing to have different types of materials, but if they're not satisfactorily tied together, then the systems can begin to break down or the components can come apart. Mass is important. The heavier the thing is, as we've learned from the 3 little pigs, the more impact resistance it's going to have. Take that little guy, run him into the big guy. Big guy's going to stand there, little guy's probably going to bounce off. And then lastly is hardness, the hardness of the materials themselves. So we can go in there and we can put things like foam or even plywood on the outside of a home, but if we don't have hardened materials like plate steel, in some cases loose set concrete brick or concrete blocks, that sort of thing, then we run the risk of having the outside wall broken through. So again, the reference that we're going to use, it's actually in its 3rd edition. And the one thing I'll point out, because I think this is really important for the business community here and business owners as well, is FEMA 320 used to just be safe room for your home. And now what they've done is they've expanded that to cover small business. In other words, if you have somewhere in the neighborhood of 12 to 16 persons in that space, that you could be able to take those persons and put them in this safe room. Not only that, in a business situation, we have computer servers, we have files, we have things that might benefit from being in a fire-resistant space. A lot of the shelter designs that we have actually will give us the ability to protect those valuables, not to mention the life beyond that. So when we talk about these shelters, a lot of times people think, that's my hidey hole, that's where I'm going to run, be safe in the storm. But also what this does is it gives us a place where other things can be kept safe in there. And you'll notice in the next few images that I have, it'll be down the line a little bit here, but you'll actually see a place where they have the disaster kit, and we'll point that out. The other thing that we have here, and I'm going to reference these projects because I think they're important as well. We learn from different scales when we do these things. FEMA 361 is a design and construction guidance for community shelters, and it's applicable, basically it exceeds applicable building codes. There is no building code that gives us a guidance for how do you resist a tornado. We just have peak average winds, not tornadic winds. The other thing that we have is FEMA 320, and whenever we start to have more occupants, then we have more need. For one, as you get more people together, the importance factor goes way up because you don't want to have a failure in a very large structure. So the guidance is slightly different as you get to FEMA 361, and we'll see some examples of that as well. So considerations that we have, first of all, is do we live in a high-risk area? I think the evidence is on the street as far as that goes. Next thing we have is how quickly can you reach safe shelter during extreme winds? Now I know there are a lot of them and get inside the root cellar, which would require them to do a couple things. One is that we require them to leave the house, go across open space, and then change levels as they went down steps to get into the root cellar. So those are two key pieces. What we're looking for is something that you can walk at the level of your house, walk straight in, shut the door, and be done. So there's no level change, there's no going from one structure to another structure. It's really just passing into that safe space within the main structure, whether it's a business or a home. Next thing that we want to look at here are what are your physical abilities or disabilities now and within the time you'll live in the home or be in the business. I can tell you, just went on a little trip, had a little sprained ankle, and I thought, my goodness, this is not fun having even a minor disability like that, let alone having a surgery or something like that where you might need to be able to more easily move into something like this. And the idea of moving from one structure to the other, changing levels, is just impossible. Use a set of crutches for about a week and see what that'll do to your perceptions of that. The next thing is what level of safety do you want to provide? Is this important to you? Is this something that you want to take a risk with? We can always use the idea that the conventional wisdom was go down in the basement, get up against the wall, stay away from the glass, and that's worked for a lot of people. But what we do find is that structures come up, they set down. If we're against a wall, the structure comes up and sets down off of the wall, then we have some problems there as well. What is the cost of a safe room? I think is important to all people. And then what is the cost of not having a safe room? And I think we have plenty of examples of that as well. So when we look for a location in a residence, the shelter can be anywhere. Ideally, it's in the center of the structure. If you think of it this way, the outside of the structure is more or less of a buffer okay? It can absorb impacts. It can actually sustain some of the initial wind and flying debris. And so if it's in the center, that's probably the best. Other options that we have then are to place it into a corner, or in some cases, if we just want to maybe do an addition, you can actually place one on the outside of the building footprint. Now, what we also look for are places that we can put these in the house. And we have here, it looks like a master closet. You have a bathroom. You have a kind of a closet or a pantry maybe that's out into a hallway here. So that's in the central location. Another central location might be a mechanical space or a laundry space. The thing that I point out is, you know, if you had this set up here, for instance, now one thing you'd have is you'd have all these doors that you'd have to shut in that instance, but you could get people in each of these spaces. But if you do use a bathroom, for instance, after the storm happens, more than likely you'll still have bathroom facilities, okay? The sewer is still going to work. Whether or not you have water pressure is another story, but you could probably quickly be back into restroom facilities. So that's one thing to consider as well. So in Moore, Oklahoma, what did they do after they got hit by a couple of these? They determined that that inside portion was important. They went back and they rebuilt slab on grade. And when they did it, they created these, in I think this case it's a bathroom. We also have, like I said, the potential for this to be a pantry. The advantage of it being a pantry is that you might have food stocks, water supplies, and etc., kind of your standing disaster kit above ground, if you will. So now, as far as foundation and tie down goes, yes, we can still have these in the basement. As you see here, we've got a concrete slab and the shelter on top of that. You'll notice here that we've got the emergency kit placed in the corner, and then this hardened construction out and around. We're not being specific about that because, as I said, in the document we talk about concrete block construction, concrete poured construction, stud with a steel face over it, and then also stud with plywood, and then ballast in between the studs. In other words, concrete bricks stacked in there. So we've got the foundation here. The most important thing that you'll see is that you never have this sitting off of soil and a solid slab. You'll notice here in a house that has a crawl space that they've actually gone in and they've created a slab on grade condition up inside the house so that the structure can sit right on that. And it's important, again, that it's all tied together and that this is a hardened structure. On the slab itself, again, up and above, connected. The basis for this is the interior room that survives. And in this case, you can see another option. This is an insulated concrete form with a hard door in it. And one thing I'll point out about the standard too is that the doors are actually designed to be in-swinging. Okay, the in-swing, they have 3 deadbolts on them. And the idea behind the in-swinging door, somebody says, well, you know, if the debris is going to hit it, it'll knock the door open. Well, ask anybody that went through this last storm what happened as the storm passed over. And what you'll notice is that there was a lot of pressure change. They talked about the pressure dropping and their ears popping, that sort of thing. And if you have that door shut and the pressure changes, what's going to happen is that door is actually going to press into the stop and into the jamb. And those bolts are there, yes, to take any debris that might hit the door, but more than anything, it's the suction on that room that would be a problem. And I don't know how many of us have seen the movie Twister or dare to even watch it after what we've just experienced here, but in the very beginning of that movie, the gentleman was down inside the root cellar. He was trying to hold the root cellar door shut, and what happened? Root cellar door pulls away, and he's sucked out of the space. So the doors swing in, and that's an important aspect of this. The most important thing to understand is that when you talk about these standards have been tested by the Texas Tech Wind Energy Laboratory, okay? And when they do this, they've set standards on the different aspects and how they perform. So I'll see if I can get this to work. On our first run, I'm not having high hopes, but we'll see what happens. This is a 14-foot long cannon. As you see here, they put a plug on the end of a 14-foot 2x4. It's pneumatic. They shove this thing down in here. This is a great job. If you're young at heart and a little boy, this is a lot of fun. But they launch that thing out of there. These go at an excess of 100 miles per hour. And if you think about the weight of a 14-foot 2x4, that's about a 5 to 10-pound projectile. And you can see here they lower different systems down into the blast zone here. And I've got a couple of these. I won't bore you, but this is a wood stud wall, basic construction that we're used to. And you see that the 2x4 went through. The little cap actually flies off as it goes in. It rips the screws out and drops the cap. But that thing pierces with this nice clean hole in through that wall. When we start to look at more hardened systems, and the ICF contractors love this one, insulated concrete form. Here you have styrofoam block with a brick face on it. It hits it, there's damage to the brick. There's really very little damage, if anything, to the ICF. In some cases, it maybe dents the foam for the block, but there's no structural damage whatsoever. Again, this is not with the brick face. This is just a vinyl siding over that foam. And it goes in and it sticks because basically it hits the concrete and mushrooms out. And as you can see there, the concrete actually itself is in pretty good shape. To prove it, they flip it around, they hit the backside, and in this case, the foam is destroyed because that's the first thing. But you can see what happens to the end of that 2x4. Now, didn't know it until about a week later that we weren't supposed to have these photographs, but what we do have here is a demonstration that was done after 9/11. You can see this was May 6th through 8th in 2003, which is really kind of ironic because we just had the Battlefield, Pierce City tornado come through at about that time. What they were doing was they were trying to demonstrate force-resistive construction for military purposes. So they built these three-sided box structures, basically walls, floor, and ceiling, and they left one side open so that there would be the ability to change pressure and so on. But in this case, we have one of the ICF manufacturers, another one to the side, and then on the back you see this black wall. That's a blast wall, and they put 50 pounds of TNT against that wall. They shot it off right next to these structures, and then when you go in and you have a good look, one of the structures, the actual blocks were white, and this is the white one. Okay, whenever it exploded, it collapsed the foam, and these little splines that you see here actually pushed out and knocked a little piece of styrofoam off the face. So think of it as just like a great big shock absorber. It hit and compressed. It didn't hurt the concrete at all. They had structural engineer Stephen Baldridge who looked at it and realized, you know, yeah, there was some burning on the foam, but there really was no visible failure inside as far as the structure were concerned. A quick case study, and I'll tell you, these are, again, FEMA 361. This is kind of the higher standard, but it's important to know that we have structures in Missouri that have been built. The commercial and institutional contractors are familiar with this, and I think that our residential contractors will be as well. May 6th of 2003, we had the Battlefield tornado right here. This is the firehouse in Battlefield. The roof was basically picked up and twisted, and as it was being picked up and twisted, the concrete blocks fell. The firefighters that were there that night ran into the bathroom. It was a small concrete block room. They survived, came climbing out of there, and the first thing they got out was the backhoe to clean up. Again, the house just a block away. So what did we do? Back at that time, I was working with Missouri State University in the construction management department, teaching construction science, and was also consulting with a local architecture firm. We talked to the Concrete Promotion Council of the Ozarks about maybe adopting this, at least in the case of Battlefield, as a project to demonstrate force-resistive construction. So what we did was we set some goals here. We looked at an F2 and an F3 situation. We wanted, in that case, to be able to survive that. The fire chief didn't, at that time, want to go through the whole FEMA program and so on, but he wanted assurances that we could withstand the F2 and the F3. So what we created was a program here. We wanted to have 6 truck capacity and all this good stuff. But the most important thing was to get down here at the bottom and have an F3 rating for a dormitory shelter and a 200 mile per hour, 3-second gust, and an F2 rating for the balance of the structure. In other words, you could blow the doors out of the fire bays and the fire station would stay intact. What did we do? We went and we looked at some precedents that we were trying to study for how you're going to create a firehouse that can provide that kind of performance. So the first thing we looked at was FEMA 320. It preceded FEMA 361 in August of '99, and it showed us that if we created concrete structures with good connections, as you see in the image on the left there, that we could resist these forces. The other thing we looked at, oddly enough, Branson gave us a good example. We went down there, and there was a condominium development on a really tough site. It was really tight. And they wanted to create an enclosed pool structure, and they also wanted to have a tennis court on the site. So what did they do? They stack up these foam blocks, and they bring in precast elements, and they sit down on top of this thing so that they can have the tennis court on top and the swimming pool down below. Well, we were intrigued with the span that they were able to get, and we talked to our engineer about that, and we were able to use that span to span across all 3 doors and come up with basically a 10 by 60 module that would help us out here. So when you look at this building, you're basically looking at components that are 10 by 60 in their nature. These are some shots of the construction. When it first went up, somebody thought that somebody made a mistake and that the fire chief was building the jail. That's actually just a lot of rebar to hold all this construction down. We did some estimates of the overall weight of the building. It came in at right around 3 million pounds. Lots of steel reinforcing in the walls. Lots of coordination of construction. And this contractor had not done this before. We went in, looked at ways that we could get the precast to fit together in a way that we were comfortable with. You can see the walls stacking up here. And these were poured, I do believe, in a single pour. Lots of gussets and so on for bolts to attach structure to this. You can see the precast elements being hoisted into place and how they look. And then on top of this construction, we were able to put just conventional brick ties and block in this case. As we came up to the top, we took the wall reinforcing, overlapped to the roof. On an 18 by 18 grid, provided more reinforcing up there. So anywhere inside the structure, you had basically 8 inches of reinforced concrete between you and the outside. And here you can start to see it take place. This is November 6, 2003. They cut the ribbon on this thing basically 9 months after the initial loss, which was pretty miraculous. Now, important in this were people that will work with you. This old gentleman down here, some of you may recognize him if you've been around construction for a little while. I went out there and I thought, oh boy, I got an old fellow with white hair and I'm going to build something new with him. This is going to not be very fun. Sat down with him. He'd already had tabs put in the notebook, went through and he asked about 5 or 6 questions. And the last question he asked is, where's this stuff been for the last 40 years? My back would have really appreciated it. So, Pierce City, similar situation. We actually went through the whole process in that case of going through FEMA, getting monies for mitigation and a community shelter. The design changed. Sometimes you have to come up with a big idea and then scale it back. What we ended up doing is taking this little piece on the left and tucking it around back and making a community storm shelter for the residents within a 5-minute walk. And just to give you some ideas, You know, these numbers are old at this point. I mean, honestly, whenever you put numbers up, give it 3 months and they're not worth, you know, what they're showing again. But at a snapshot in time, we took a good look at metal building structure, and it was somewhere in the neighborhood of you know, below the $95 a square foot mark. Whenever you come up through here, the PEMB is pre-engineered metal building, okay? And so when you start to look at the different steps that you can take through, we were actually up at, excuse me, about $109 a square foot. This is what the final product looked like here. You'll note that the door frames that you see here are completely welded into steel that is poured into the outside wall. The other thing to look at, and people ask this question as well, is, okay, I've got this house, you know, I'm getting all this information about construction and so on, and this is where I'm going to give a little bit of a pitch because I have had a lot of experience with insulated concrete form, and we're going to talk about green building later on today, but I'll just put this one out here. This is research that was done by the National Association of Home Builders Research Council back in 1999. And what they were doing is they wanted to see, you know, what would the additional cost be for replacing 2x4 wood framing on the exterior wall with insulated concrete forms. Now, we know that there are cost differences in this and so on, but in this case they estimated about a 2 to 5% increase in hard cost. That's overall. Now, line item by line item, it can scare you to death because it is a big chunk of money right up front. But we've seen anywhere between 7 and 10% in overall cost increases. Now, that being said, in this example, and I think it, you know, if we just go with them for a second here on their example, if you take the 200,000 square foot house and you look at just the increase in cost of construction, you know, say it's 8,000 or even, you know, 14 to 20,000 more, as you start to work your way down through here, the principal and interest is actually a little bit more because you're spending more. The taxes are a little bit more. The insurance, it drops. And the reason that that drops is because you're dealing with, one, a hardened outside wall, and two, there's a fire resistant aspect to it. Additionally, you get down into the energy here. Now, I have done personally the calculations on these. I've designed and built 7 of these structures from residential additions all the way up to the great big firehouses. And when I've done this, I've been able to go in, and in one case in a residence, the contractor, the HVAC contractor comes out, he measures the thing out, and really didn't take into account the concrete outside wall. Did his calculations, it's a 2-ton unit. There's 1,400 square feet, that's 2 tons. Okay? I took a software package that's available from Portland Cement Association, PCA, ran the same design through there, came up with a 1-ton load. So that's 50%. And then just to go through and do, you know, the practical aspect, the common sense aspect, they didn't need the air conditioning until the middle of July. Okay? That's a pretty big statement as far as how much of that heat can be put off by the heavier construction. It's something that we've known for a long time. Settlers in this area, they used sod construction to beat the heat. They also, in the southwest, the Pueblos used a heavier construction to offset the heat getting to the inside of the structure until later in the evening. Now, these are some values here which are based on the second edition, but I can tell you that even if you were to double these, okay, these represent replacing construction inside the home with the hardened construction. So let's just say, for instance, that we doubled these. In a basement situation with a lean-to, your average cost might be up to $6,000, okay? Most of the time you don't have construction, so that's new construction. You're not replacing anything. When you come down here into the slab on grade, and let's look at, for instance, wood frame with concrete masonry infill, $4,000, or wood frame with plywood and steel sheeting, you're basically putting a hard skin or ballast inside that wall. You're $4,500. You might bump that up to $7,000 or $8,000, but you're still providing a pretty hefty structure in there, and you're replacing some of the construction. Now, if you come back later, I'll have in the new information, but the new information basically says, just for instance here, in an 8-foot by 8-foot by 8-foot safe room, if we were to do it out of the insulating concrete forms, the current estimate based on FEMA 320 is $8,300. If we were to do the wood frame with concrete infill, $7,600. And here, the wood frame with concrete infill was $4,000. So you're just about a doubling based on this. So, you know, those are going to be the high-end dollars, and I think what we see is that people are more inclined to build these. Our numbers for these are coming from areas that have been hit, so the construction costs are maybe elevated a little bit. But, you know, this being what it was, those are fair numbers. The one thing I did want to get to here, and I failed to do that a moment ago, is when we look at all this, we can see that we have reduced insurance, reduced energy cost, but look down at the very bottom here in the comments, and just imagine even if it was another $12,000 in the value of that house, if we're looking at $1 a month more, you know, how much more a month would you be willing to put into a mortgage to have something like this that would, in some cases, reduce energy, reduce your insurance, and give you the kind of sense that you're going to be all right living in Joplin, Missouri. So with that, here's some of the resources from the Portland Cement Association, concretehomes.com. There's catalogs and helplines that are out there, and I believe they're going to have this on the website later. But more importantly, if you need to get a hold of me, and of course it always happens this way, my email address, because it's not showing up there, is barberj, B-A-R-B-E-R-J, @missouri.edu. My cell phone number is 417-343-5682. And I encourage you to give me a call. I'm the housing specialist for the state of Missouri in Extension. And if you're interested in doing this, whether you're a builder or a homeowner, and you just want to talk about some of the aspects or review the drawings, you're certainly welcome to do that. If you're a builder and you're committed to doing one of these, I want to come out and see it, first of all. But second of all, I'd be willing to part with one of these if you're a builder that's committed to doing this. The nice thing about it is on the CD, online as well, you can download the drawings, take a look at the construction type that's right for you, talk with your builder about it, see what's right as far as they're concerned. And again, I would just encourage you to look for one of the many ways, as you see in the cost matrix here. Those are all the different options that you have for getting that safe room in your home, built by your builder and local skilled people in a way that you can monitor. We can always go out in houses that have been built. We can retrofit by buying a unit that we bring in and set in. That's acceptable. I go back to my first comments about, can you walk straight into it? Do you have to change levels? Do you have to go from one structure to another? Those are all strong considerations. The other thing is, in this, you know, you do have the local contractor that is able to make sure and verify with you that the guidelines are being met.